This fourth problem, we're going to deal with the cross product. Okay, the cross products of two vectors. Okay, what is a cross product? We will be able to demonstrate here what is a cross product of two vectors. So first, we have three vertices of a triangle. So we have a triangle A, B, and C. Okay, and then so you have the problem is asking for the cross product of RAB. So this is the RAB, then the RAC. So you have the two RAB and the RAC. Okay, so the cross product of these two vector. So later we will demonstrate what is the physical meaning of this cross product. But in this video, we're going to solve. Okay, to solve mathematically, and also the second problem is asking for the area of the triangle, and then for the last one is the unit vector perpendicular to the plane in which the triangle is located. Okay, this is very simple. First, how to find RAB. So let's proceed first to RAB. From the previous video, we simply solve RAB by directly subtracting P minus A. So the point B, so you have negative 2 minus A, which is 6, and that is for your, I will use I. Okay, this directional. The previous video I used AX, and I'll be using I. Then plus you have 3 minus negative 1. Okay, this is for the J. Long Y, that's then negative 4 minus 2 is long K. So we have negative 2, so we have negative 8I. Then we have plus 4J, and then minus 6K. Okay, so these are directional vectors. So that is your RAB. Okay, then you have RAC. RAC is the same pattern, so you have negative 3 from your point C and along X, then minus 6. This is your I, plus your 1 minus negative 1. That's your J plus 5 minus 2. That is your along Z axis. Okay, so you have here you have your negative 9 I for that I plus so this is plus 2J plus 3K. Okay, so you have your RAC. Now for the cross product, this is how it goes. Now take note the position RAB cross RAC, not RAC cross RAB. So they are not the same. No? If you interchange this one to the other side and then this one to the other side, they are not the same. Okay, so be careful with that. So very simple. You just write first the directional vectors I, J, and K, and then write the values first from the RAB. So you have negative 8. Create a matrix format like this. Okay, given from this your vector. Okay? And then the second one is for the RAC. Okay, 2, 3. So you have such a matrix. Okay, so now if you have RAC cross RAB, so these two will interchange. Okay, so right, very simple. You just need to get the determinant of this matrix. Very simple. First you write the positive, you have the that one here you write the, okay, so you have, if you are dealing with your I, actually you create small matrices. When you're dealing with I, so you need to take this box. Okay, need to take this box. Okay, so the 4, 6, negative 2. So this is actually getting this this 4, 2, negative 6 and 3. You have 4, 2, negative 6 and 3. This is for your I. Okay, then minus for your J. So you except 4 and 2, the one directly below, so that should be negative 8, negative 9, negative 6 and 3. This is for your J. Now you may ask why there's a negative sign here. Okay, so I will discuss after this. Then for K, so you have except negative 6 and 3, so you have negative 8, 4, negative 9, 2. It's for your K. Now, as I said, why is it I minus J plus K? This is the case, so this is the pattern. You have plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so take note. If you have more, then the fourth one is minus. Okay? So it follows this order. So you have plus, the other one is minus, plus, minus. Okay, so that's the rule in this form, no? The cross. So then after these four smaller matrix, so you need to get the determinant of this. Very simple. Just multiply 4 and 3. Okay, 4 times 3, then subtracted by the multiplication of 2 and negative 6. 2 and negative 6. Okay, and then this is for your I. Then minus the same pattern, so you have negative 8, then you have this is positive 3, this is 5 times 3, then minus negative 9 times negative 6. Okay, that's for your J. Then plus, okay, plus negative 8 times 2 minus negative 9 times 4. Then for your K. Okay, you just simply solve this one, then you will get the answer. So using your calculator, we can solve for this. So the final answer is 24I, 78J, and 20K. So if you look at this, actually the physical meaning of that is you have this vector A, RAB, then you have RAC. It's actually sorry, if I change the sign first. This is RAC, then this is RAB, the bottom. Now RAB cross, okay, RAB cross RAC is actually go. If you use your right hand rule, your RAB to RAC, you will actually get this. Okay, so the thumb, your right hand thumb will point this way. Okay, so RAB cross RAC, and your thumb is pointing upward. Okay, so this is actually the value here. Okay, then if you replace RAC with RAB, okay, if you interchange, this becomes it's become RAC, RAB. You will notice using your right hand, the direction will go downward. Okay, so most probably the values here becomes negative. Okay, or the opposite of these vectors. So be careful, so don't interchange RAB and RAC. Unlike for the dot product, you can interchange. Okay, so that's the physical meaning. So we have solved problem A. For the problem B is very simple. Okay, we know that problem B is the area of the triangle. So assuming this is our vector, RAB, then RAC. Now the formula for the area is equal to 1/2. Actually, the two sides are magnitude of RAB and RAC, sine the theta between them, sine theta BAC. Okay, that should be BAC. So we've learned in the trigonometry this formula. Okay, this is very important. The two sides, okay, the magnitude cross multiply, so the product of that sine the angle between them is actually the area corresponds to this. Okay, so this is the area. Now if you don't put 1/2, so that's the whole area here. Okay, so that's why you put 1/2 so that it will just simply a half of it. Okay, so this is the area we are looking at. So in this case, looking back to the formula for your cross product, actually the cross product of RAP cross RAC is actually equal to the magnitude of RAB times RAC sine the theta between them, BAC, times the unit vector. Okay, I will use a unit vector n. Okay, so this is a unit vector. Now how do you so this is actually the area. Take note, this is the magnitude, this is the scalar value, this is a magnitude of the unit vector un. So actually we can get this value here from the magnitude of RAB times RAC. Okay, then 1/2. Okay, so let us try to solve. This is actually equal to 1/2 to the square root of the magnitudes here. Okay, so you have 24 squared plus 78 squared plus 20 squared. So if you solve this one, so the answer is 42.01. Then the unit is unit square or square unit, SQ. Okay, so very simple for your area. Okay, now take note of the 1/2. Okay, so cross product is very important to get also area. Okay? Just get the magnitude, that's it, you can get the area. Now for your C, we're looking at the unit vector perpendicular to the plane in which the triangle is located. So the same here. Okay, if you note in this case, if you remember this case, so you have the two triangles, two sides, and then the answer, this one is the RAB cross RAC. Okay, so what we're asking here, the unit vector perpendicular to the plane is actually the UN. Okay, this one. How do you get UN? Okay, very simple. From this formula here, okay, so you have UN is equal to the cross product or the vector and then divided by their magnitude. So the magnitude of RAB cross RAC. Okay, this is actually equal to the magnitude is 84.02. So therefore we have this expression 24i plus 78j plus 20k, okay, divided by 84.02. okay, so therefore the unit vector, so we can check the unit vector because it's always less than 1. So the answer here is 0.286 I plus 0.928 J plus 0.238 K. Okay, so that's the unit vector. So this is the vector, the unit vector, because this one can be expressed. Okay, this vector here, the cross product, can be expressed by the magnitude and then a vector or a direction. Okay, the magnitude and the direction. So this one is only the direction, and then the magnitude, actually the magnitude is 84.2, and then that magnitude is directed to this unit vector. Okay, that's the physical meaning of that this value. This is only the direction. The magnitude is the 84.02. Okay, so that's it. So thank you for listening.